Thank you all for showing up, kind of late in the afternoon, but glad you guys are here. My name is Bryce Curtis, and I work in the research and development team at Discover. Now I've been involved in open source for many years, kind of my past jobs. I led the Apache Cordova project probably about a dozen years ago now. And then most recently, I led the Discover's first open source project. It was called Theme Builder. And it was contributed to the FinOS Foundation, which is associated with the Linux Foundation. And then just past 2 weeks ago, I guess, Discover open sourced the FinOCR project, which is OCR for check processing. And that was also contributed to FinOS. So today I'm going to be talking about operational data stores for financial risk mitigation. And this is another open source project that I'm leading at Discover, and we are investigating open sourcing this as well, possibly later this year. All right, so for the agenda, I'll open up with talking a little bit about open source issues and how we manage that for our enterprise. Then I'll be talking about SBOMs, I guess something that we've heard a lot about at this conference, and how it can be used to describe the software and dependencies that we have for our applications. Then I'll be introducing operational data stores, or ODSs, describe what they are, how they can help manage our applications. And then finally, I'll talk about how operational data stores, or ODSs, can be used for proactive maintenance of the applications. All right, so I know all of us here, we're very big proponents of open source. We understand its value to both our companies and the community. But I'd like to just underscore that with a couple of statistics and numbers. First of all, about 90% of the software that enterprises develop end up using open source in them. And then we heard this morning, it was actually quite interesting, Frank Nagel talked about the work that he had done as part of Harvard Business School. He mentioned the same number here, $8.8 trillion if you were to try to essentially write all the software that we end up using in open source in your own company instead, if we weren't sharing anything. So that's a huge number, enormous benefit, but there are some challenges associated with that. So we've heard a lot about vulnerabilities, bugs that can impact our applications, and then new versions are often released then to address those issues, or maybe even add additional capabilities to these libraries. So being able to stay on top of these different libraries that are being used, it's important to do that for a number of reasons. There's also licenses that we have to be aware of. There's several different types of open source licenses, and they have implications for the applications that we use them in. And then there was several discussions just earlier this afternoon, licenses around ML models. They've been talking about, and it kind of sounds like it's where the software industry was as far as licenses were several 10, 20 years ago. So there's still work that needs to be done there, but those are things that if you're writing an application that an AI application that brings in these models, you have to be aware of that, and you have to know kind of where this data came from. There's also levels of support that we have for open source software. And it could vary anywhere from, use at your own risk to well-defined support. So there's a lot of variability there in supports. So now if we take a look at that 90% number and kind of dive into that a little bit, an enterprise may have hundreds or thousands of different applications that they write. And each of those applications, they have dependencies that they bring in, open source software. And those dependencies, a lot of times the developer will identify the dependencies that they select in their package.json or build.gradle file. And those are the ones those are considered kind of top level dependencies, the ones that they select. But those dependencies also bring in other dependencies. They use other open source software. So you may have around 10,000 or more different direct dependencies in your enterprise, but you can end up with 100,000 or more different versions of various open source libraries that you end up having to worry about and manage. So these are large numbers, and we really need to have a way to efficiently stay on top of these libraries. All right, so suppose you received one of these emails in your inbox this morning. The first one is, what versions of Spring Boot are used inside your company? And then list all the applications that use them, identify which apps are using the older versions, and which ones should be updated, and specify what versions they should be updated to. So that's kind of the first question or email. The second one is a zero-day vulnerability issue. Suppose there's a zero-day vulnerability for Axios, which is a library that's used for JavaScript and in Node. Identify the products that are affected and notify the teams for remediation, and prioritize products that are used by customers. So the question is, if you receive this, well, first of all, how long do you think it would take you to answer these questions and deal with these particular concerns? Would you need to assemble a team? Who would you go to help you with these answers? And then how long would it take? So this is what we're going to talk about today, how we can answer these questions quickly and easily, and then many more other questions like them. So first of all, kind of general considerations around open source. There's licensing concerns, which have been talked a lot about in the different conferences. Open source licenses are free for the most part, but they do come with kind of obligations that depend upon how you can use the application or the library for your particular use case. So you're probably familiar with Apache or MIT licenses. And for the most part, they're free and they can be used for just about anything that you would want to in your enterprise. There's also licenses that do have some obligations, like if you use this particular software, you have to open source any application that includes it. And those are called copyleft licenses. An example of one of those is AGPL, et cetera. So you have to be aware of the licenses that you're using. A second consideration are around vulnerabilities. It's important to stay ahead of the vulnerabilities, and you probably get notified of them in your build, so you can fix them before you're really allowed to continue. But vulnerabilities can happen after build, anytime during the production cycles. So it's always good to be able to keep software current, so that when these fixes come in to address these different vulnerabilities, we can address them quickly and easily. Now, this is one of the challenges, though. If you don't stay up to date, then some of these fixes may come in, and the delta between what you're currently using and the new current version can be substantial, to where you have to now change your code in order to get it to work. So that's one of the reasons that you want to be proactive in staying up to date with the different releases. There's also zero-day events that happen, and those need to be addressed quickly. So the more current we are, the quicker we can respond to those as well. And then there's additional things that we need to be concerned with, mainly around community. Is the community, the ecosystem, is it healthy? Do they maintain their code base? Do we know if it's still active, or maybe it's been archived? And so these are all things that aren't necessarily, checked or validated during your CI/CD pipeline, but they do make a difference, and they can change after your application has been deployed. So there's a lot of things that we have to kind of be concerned about as we think about maintaining our open source software. So how is information discovered? Well, this is where it gets a little bit more difficult. The information that we need lives in a lot of different places. There's open source software that's typically maintained in the GitHub repositories. They'll have READMEs, and they have support documentation, or they don't. Depends. Sometimes it's referenced in READMEs, sometimes it's in a markdown file in some directory down, in some hidden directory that's hard to find. But it's really time consuming if you want to try to determine what the support is for all these different packages that you bring in for your library to your application. So that's the first thing. And then package managers. This is where the code lives. This is in like Maven or NPM repositories. And they often include the current version along with other available versions or licenses and other types of information that's included there. And then there's open source scorecards that has been discussed, I think, at this conference. There's a standard emerging around with the Linux Foundation. The scorecards, they basically take GitHub metrics and they build a rating with that information. So these ratings occur across several dimensions, anything from vulnerabilities to maintenance scores to testing. And they're all really good sources of information that you can use, particularly as we think about how we define policies around our controls or our guidances for these next layers that go beyond just the licensing and the vulnerabilities. There's also internal package managers, and these proxy the code that's actually used during build. And then this is where our different rule sets live and where things are enforced around our policies. So either licensing policies or vulnerability policies. This is responsible for enforcing those so that you don't get these vulnerable packages actually in your product deployments. So now CMDBs, the last one here, this holds our application information. And it's important because it also has relationships to other products. It can have teams and even policies and controls that are all referenced here. And this is the bridge that allows us to correlate all this additional business data that we have to applications at the various different life cycles of the application itself. So many organizations, they struggle with how to get their arms around this huge number of open source software that they consume. SBOMs, or software bill of materials, was developed and is actually useful for this. Now SBOMs, they got a boost several years ago by the US government requiring that all suppliers provide SBOMs for all the software that the government uses. And there's also other organizations like the Linux Foundation as part of the Open SSF that include them as well. So SBOMs, they basically describe the inventory of software components and services, and then the dependency relationships between them. And we mentioned the top level are the also called transitive dependencies, which are captured by an SBOM, but they also have license information, vulnerabilities, and other metadata that's really useful for kind of capturing the operational state of the enterprise in that application. Now, there are several formats or specifications that have been used and are used throughout the industry. There's a Cyclone DX specification, which includes SBOMs, but it also has other types of BOM representations, which are actually quite interesting and are useful for other types of applications. There's the SPDX, which stands for System Package Data Exchange, and this was introduced by the Linux Foundation. And then there's also a couple of others, SPOX and SWID. And the reason there's 4 or more is that they all kind of had their initial use cases when they were first created. So they were created to address those. Now, Cyclone DX is the SBOM spec that we chose to use at Discover. And this is because it represents additional types of assets that we are interested in particularly AI ML models, which is something that we're starting to use more and more at Discover, and then attestations. So on the right-hand side is the spec for the Cyclone DX and kind of the different properties that are listed there. Some of the interesting properties that we use, there's metadata property that includes component information like the software name, version, descriptions. It also has, author, supplier, so you can understand the pedigree of the software that's being used, and then licenses. The components, this is a list of the different open source libraries that are brought in and used by this software. And then dependencies. It really builds out the dependency graph so that you can identify those that are top-level dependencies versus those that are brought in by those top-level dependencies called transitive dependencies. But all of them are listed in here, so it's kind of a complete description of everything. The compositions list, it lists components, but it includes other pieces of information as well, like applications, what applications this particular product may use, links to other services that it may use, or APIs that it may implement or consume. They're all part of this compositions list. And then, of course, vulnerabilities, which are talked a lot about in open source. It's a list of all the different vulnerabilities for all of the components that are brought in and used by this application. And then finally, declarations. It includes claims, evidence, and attestations that describe conformance to a particular requirement or specification. So SBOMs are great, but there are challenges to using them. As we mentioned earlier, there's a lot of these different tools and sources of data that we use in an enterprise. And so while some of these tools may generate SBOMs, they only contain details that the tool knows about. So for example, a CMDB system may know about applications and teams, but they don't know anything about vulnerabilities or the software that's being brought in by that particular piece of software. Conversely, the internal package managers, they know about vulnerabilities, but not product teams or business controls that need to be applied to that application. So basically, there's no one tool that, and its corresponding SBOM that include the full context of the application. And so in order to create this full context, it is quite resource and time intensive, takes a lot of information. And so we're going to kind of look at that. So to create this context, we have to retrieve and correlate data from all these different systems. First of all, we have to assemble a team that knows, first of all, has access to these systems. That's not necessarily a given in an enterprise. And then how to query these systems. And then we have to correlate records, normalize the data, and a lot of times it ends up in a spreadsheet somewhere that then we can use to answer the question. But this can take hours or longer to do for each type of question that's asked. Now, if this data needs to be filtered in a particular way, maybe the question is, well, what applications of mine use open source libraries that are older than 6 months? Well, this could take a long time to determine. So fortunately, these types of questions are usually concerned more around maintenance than single zero-day vulnerabilities, but they often aren't asked because they are time-consuming. But either way, without automation, the lack of speed and repeatability can be adversely affect decision-making in these situations. So there's several use cases that we encounter often at Discover. There's inquiries that we may receive about what OS software is being used and which versions. Maybe there's a compliance review where we need to find out which open source software is being used that's outside of our guidelines or guidance. And then we've mentioned zero-day events or vulnerabilities. For a particular product, an asset, what's the blast radius, or how widely is it used, and then what's the impact to our business. And then maybe IP reviews around licensing, kind of determine what the impact is of that. So to answer these questions, if we think about, well, wouldn't it be great if we had kind of a single database that had all this information that we needed, all the different SBOMs and community information like scorecards and maintenance information, so that developers, product owners, and even executives could query this information and get the answers that they needed in seconds rather than hours or days. So that's what operational data stores actually do for you. So an operational data store is a database that integrates data from these multiple sources for near real-time operational reporting and analysis. And it really sits between kind of the source systems and then the data warehouses. Now the key characteristics are near real-time integration that provides a snapshot of your business. And it does this because data is refreshed frequently, often hourly, so that we have current operational state of our different applications. The second one is single integrated view combined from multiple sources. With a single source of data, now we don't need to query these multiple databases in order to get the operational state. And then the next one, subject-oriented around business subjects or entities. These may be customers, products, teams, or controls, rather than just the application process itself. And then volatile data, as new information arrives, this kind of goes along with the near real-time integration. The data is updated frequently, and it's not static like what you would necessarily have in your data warehouse. And then operational data reporting for really day-to-day business operations. This means that we have reporting for vulnerabilities, licenses, inventory management, and fraud detection, things that we're really interested in day-to-day that kind of change day-to-day. So benefits kind of correspond to the different characteristics and what the values are there. The enhanced context from aggregating related SBOMs and community data. This is very important because it allows relationships between the data that we have to be discovered. And then because of this, it provides a more complete view of the operational state of the applications within our business. And then because of the broader context and the access to this up-to-date information, ODSs enable faster and more informed decisions to be made. And then since we're saving data in a well-defined data model and database, it serves as a single source of truth for our operational data. And so that means that business processes can efficiently access the data. They don't have to go to multiple places. Then finally, by having a single source of truth, report generation efforts and costs are reduced significantly. There's no longer multiple data sources that reports have to do, or the tools. A lot of times there's the tools that are specifically for those particular sources of data. Instead, now we have a single query language that we can use along with a single tool that generates reports. All right, so the use cases that I mentioned earlier, they were taking a significant amount of time and resources to address. So because of that, about a year ago, we started looking at how we could automate them, and we could then kind of reduce the time that it took to go from minutes down to minutes rather than hours or days. And then in addition, make it easier so that product owners could use it for themselves. So what we did is we built an operational data store to provide this capability. With it today, now product teams, they can get answers to the questions that they have about their products quickly and efficiently. Cybersecurity, they use it extensively to be able to access and assess the impact for zero-day vulnerabilities and to kind of determine how widespread the usage is and the impact is. And then businesses can respond to audits much quicker. So our ODS consists of 3 different layers. At the bottom is the data that we consume from the various tools and communities. The middle is our ODS framework, and then the application layer that sits on top of it. Diving a little bit deeper into the ODS framework, the data model that we use is built on top of the Cyclone DX spec, which we've extended with our Discover-specific properties. Now, this is important so that we have a consistent way to query the data instead of using these various systems. And then you don't have to have the query language that all of these systems require, their APIs or endpoints in order to get to them. And so really that's the responsibility of the ETL server, is to query all these different sources of data and either create or update the SBOMs and the data model that we have in the database. Now what we do at Discover is we update this several times a day so that we have all the latest information and operational data that we need. The API server enables the various ODS apps to query and retrieve the data in the data store. And one of the apps in particular, the open source software app, we really wrote that to address all the common use cases that we encounter at Discover. And so it provides a UI with tables and handles, as we said, the most common use cases. Now, if it's not a common use case, there are queries that anyone that knows JavaScript can write to be able to query the information and get the data. And then if you want additional information, we have a JavaScript notebook, which is similar to the Jupyter notebook. That's useful for doing research, saving it off, and sharing it, and of course doing more advanced queries. So there's two additional blocks here that's in the ODS framework. There's the guidance block, and what it does is it implements our software policy for the versions that we recommend and what maintenance is suggested for these different open source libraries. And then the attestation block, that takes this guidance and generates notifications for issues that product teams need to be aware of and to address. And it also provides an auditable trail of software disposition for the applications. All right, so this slide shows kind of how we build up the aggregate SBOMs into a single one that represents the application. We start off with the Cyclone DX spec. Now it's extensible with properties. And in fact, there are several third parties that have registered extensions to the spec. So what we did is we added our properties that are relevant to Discover. And we do this primarily to speed up the queries and to be able to find the data much simpler and easier from our ODS. And if we need to export the SBOM into the standard format, we can easily convert these into the Cyclone DX properties arrays. So first of all, we start off by filling out the SBOM object. We create the SBOM from the CMDB data that we retrieve there. And on the left, you can see what we fill in there is we fill in the metadata component information, the name, version, description, et cetera, from the CMDB data. Then we also add the CMDB properties on the right that are specific to Discover. And then what we do is if this particular application implements an API, we then retrieve the API management information from our tool, for the API management tool. We add it to that corresponding property in our SBOM. And then what we do is we take our SCA data, and that gives us our components, compositions, dependencies, and vulnerabilities. It lists all of those out. We add those to the Cyclone DX properties there that are in that spec. And then we add anything additional to the IBM or to the Discover specific properties. So then what we do is we take for each one of these for each one of these components that are listed in the SCA, we end up creating a library SBOM for it. And what that does is now that creates this relationship between the products, all of the open source libraries that we consume, and then we know we have references now for every single application that uses, let's say, a particular version of a library. Now what we do for each one of these libraries is we go to deps.dev, we get the version and the scorecards for each one of them, and end up adding that into our ODS object, our SBOM object. All right, so there are several metrics and scorecards that we can use as input for setting guidance. One metric that's fairly straightforward is the version that you're currently using and whether or not it's current or not. The communities, as we mentioned, deps.dev, they have available the most recent version along with all the other versions that are available and their release dates. And if our policy states that we should be within N-2 or two different, 2 levels down from the most recent version, then we can set and identify which versions are recommended within the guidance that we apply across the enterprise. So this screenshot, it shows what versions, and I don't know if you can see it or not because it's kind of small, but it's showing what versions of Spring Boot are there. And the current version is 3.3 for our policy. The most popular one that we're using is 3.4.4. It also shows the different versions and how they're used, how many are used by the different products. Notice though that there are 92 different versions of Spring Boot that are currently being used. Well, that seems like an awful large number. So maybe this would be a good maintenance task to follow up on to see if we can get that number lower. We can also consider other community information from sites that provide scorecards or date updated or maybe a number of downloads, and use some of those factors in setting our guidance policy, really depending upon maybe the different characteristics of the application itself. So the application, for example, it may be customer facing, so we may have a different set of policies that we want to enforce for those, or it may be PCI compliant, or have other characteristics that are important to consider. But the point is that once we have this information, we can provide it to product teams and help them manage their applications more efficiently. So whether it's a page similar to the one that I have shown here that shows all the applications that need updating, or maybe it's integrated with our dev tools to automatically enforce certain guidance policies, or maybe notify owners with attestations that allow them to plan for updates and attest to what's been done once the work's been completed, or maybe request a waiver instead. All right, so we've mentioned the different scorecards. There's OSF scorecard standard with the goals stated there. Basically, the goals are to automatically analyze open source projects, to proactively improve security, and then act as a measurement tool to provide consistency with these metrics. So those are all important things. But in order to use a scorecard and the score, you really need to understand it and how it's calculated. So on the right is the deps.dev page for Spring Boot. So there's general information about the license and dependencies about the library. There's also community information around the links like code repos, issue trackers, and documentation. And then there's the scorecard information around these various dimensions. So there's the maintained scores, there's code reviews, license information, vulnerabilities, et cetera, that are listed there. Now, suppose we want to use a maintenance score. Well, first of all, we need to understand how it's calculated. Well, fortunately, they tell us it's calculated using the number of GitHub commits in the last 90 days. Okay, so that's great. That sounds useful. But what happens if the library is mature and it's perfect, doesn't have any vulnerabilities or bugs in it, right? There may not be any commits for years. And so I would say that it's probably a great library, right? It's pretty good to be using that one. So we really need to consider when we're setting guidance, all these different factors. We don't want to be replacing a great library with something that may be less than that. So for the many scorecards, there's specific algorithms that are used for calculating them. But if we think about end of life, there really isn't a good metric or a good definition or a way to define what end of life really means. So you could ask, well, is end of life even the right metric to be calling it? Maybe it's end of maintenance or end of support. And then to complicate things, products may have different ways of describing support, particularly in the open source community. It may be specified in their roadmap, or they may have a release schedule that lists it. They may have formal support timelines or no schedule at all. So depending upon the size of the project, its maturity, its governance, and what it's used for, support statements could be anything or nothing. So in fact, I would suggest that really this is kind of the next topic that we as a community need to take a look at and address and try to standardize on around this. Now, some of the work has been done to this end around end-of-life.date. They curate some of the data for some of the larger open source ecosystems. They currently track 383 different products, but they're really higher level. They're more at the language level like Java or Python. There are some frameworks, many of the Apache projects are listed there, and then operating systems like Mac OS and Windows. But they kind of stay at that level. They really don't go down to the library level. And so it's really still a manual process in order to consume some of this information. Now at the right, I'm showing the end-of-life.date page for React. From this, we can see that the most recent release is release 19. It's currently actively supported. And although if we look at from release 15 on, if there's a vulnerability or security update, at least those are still being updated. So we really need to take a look at this individually for each product that we're looking at to be able to set some kind of policy or guidance. For React, we might use this to say, well, if your application is using React, this is what we want you to follow. These are the versions we want you to be on. All right, so once we have some policies around our guidance, now how can we help teams and developers write and maintain their software? Well, one way is to use attestations. And attestations is one thing that we liked about CycloneDX that includes and supports. Now with attestations, think about we could notify teams that their application in production is using an older version of a library that may need to be updated. And maybe the attestation is that they have 60 days to update their library or request a waiver if they don't do that or if they need to have more time. Now, the attestation data model that we use is from CycloneDX, and we've really built our own attestation framework around that. And what this does now is it enables us to inform and track compliance with the updates and our policies around maintenance and even software controls. So if we're interested in, let's say, a version maintenance of an application, we identify all the libraries for that particular product that need to be updated, and then the product owner can attest to whether or not they plan to update it or not, or request a waiver and give a justification. So the attestations really give product teams notice and allows them to plan for enhancements rather than reactively do it. They are really more proactive in their maintenance and doing things that can be scheduled instead. So overall, it really simplifies their job because I don't know about you, but a lot of developers, they're writing multiple applications and they can't keep track of all the different open source libraries that they've used and that they're responsible for. So I've mentioned controls a couple of times. Essentially, a control is defined to manage particular business risk. Now, there are controls associated with software development that may specify that the code needs to be periodically updated, or vulnerabilities above a certain threshold aren't allowed, or certain level of testing must be run. So the goals of controls are that they identify who's accountable for the control, who's responsible for carrying out the particular action, and then what evidence is collected so that the control can be verified. And then because we have the CMBD data that links all the applications and product teams, we can automatically apply controls to the applications as part of our attestation framework and let it manage it instead of the product teams themselves. So how does ODS at Discover help our product teams? Well, it does this in a number of ways. First of all, proactively maintain their software by identifying the libraries and the versions that need to be updated. It also provides the community information around scorecards and maintenance that they may need to be aware of. And then by providing overall context, we can set guidance and provide that to the different teams to do that work for them so they don't have to worry about it. And part of that includes identifying potential issues that may need to be dealt with in, let's say, you know that a particular version is going to be out of service in let's say 6 months. So finally, by mapping controls to teams and applications, we can efficiently manage and lower the business risk of our applications. So key takeaways. SBOMs, they provide a standard data model that can be used to describe the application or an open source library, but it doesn't contain the entire context. And so that's what operational data stores are for. They aggregate these SBOMs to provide a more complete view. They also capture the different relationships between the systems that we have in our enterprise, and you can then include additional information like community data to enhance the overall context. And then since we have this additional information, we can then enable new use cases in our enterprise, such as setting guidance that implement our policies, mapping controls to the teams and the applications, and then utilizing attestations to help with managing those guidance. So benefits, discoverability, transparency, observability, maintenance and manageability, a lot of words there, for your software. But essentially that just makes it easier for product teams to manage their software, resulting in more stable products and overall reduction in risk. Now, there are several opportunities that still exist. We mentioned end of life. It's difficult in defining that information and what it really means, and need for really industry discussions around that particular topic. And then likewise around maintenance. How can we maintain libraries and represent those that capture kind of all the different nuances that we need to be able to use really for guidance and describing those open source communities. All right, so with that, I'd like to mention that we published an article about our operational data store at Discover. It's a really good video that's in that article that's worth looking at. And then there's a link that's shown here. You can visit that, or you can scan the QR code to view and read the article. So hopefully you'll do that. All right, that's everything I have. So any questions? I'd be happy to answer those now. As always, you can read the article. I'm listed there as on the article, so you can get hold of me that way or through the sessions here, and I'd be happy to talk to you about that more. So, all right, thank you very much. Appreciate it.